All right, welcome everybody. Pleasure to be here. And today I'm going to show you some strategies to implement observability in your company without requiring engineering efforts. If you're doing observability using open source solutions, as I am, you probably think about do the same thing that most of the observability vendors are doing, auto-instrumentation. They are just deploying an agent in your host and starts collecting your metrics, logs, and traces. So the idea of this talk is to show you some strategies using things that you probably already have on your infrastructure to start collecting all those signals and improve your developers' experience and without requiring any engineering effort. So the idea is to let developers focus on what really matters for them, okay? So I hope you enjoy and let's get started. Cool. So before we start talking about observability strategies, let me introduce myself. My name is Nicolas Takashi. I'm a Brazilian software engineer living in Portugal for the last 7 years. I'm an open source contributor, especially on the observability ecosystem for projects such as Prometheus Operator, opentelemetry, and many other projects on the observability ecosystem. I'm currently working at Logs, a streaming analytic platform for logs, metrics, traces, and also security data. And you can find me on my social media networks such as Twitter, LinkedIn, GitHub by my name. I'm usually talking about Kubernetes, observability, GitOps, distributed system, and also, of course, personal life and changing experience. So I hope to see you there, and let's move forward. Okay, cool. So now everybody know who I am. Let's move forward. Let's start talking about observability strategies, folks. So before we start talking about the strategies, see the things in action, let's ensure that everybody's on the same page. Let's ensure that everybody has the same knowledge and the same understanding about observability and the use cases, okay? I know this may be very, very basic, but this is very important to have the understanding about the strategies that we're going to see here. So folks, in the context of software engineering, observability is crucial for understanding how system is behaving. So given external inputs, and when I mean external inputs, I mean users using your system, like if you are running an e-commerce, users buying, adding things to their checkout bag, doing payments and all those things, okay? And you start collecting telemetry data. So you start collecting traces, and you start collecting logs, you start collecting metrics, profiling, and many other things, okay? And getting all those information, this huge amount of information, because observability it's very easy to start handling a huge amount of data. You can identify issues. You can identify bottlenecks on your system, where your system can be improved, okay? And you can troubleshooting problems very, very quickly. But when we are talking about observability, it's very common people start talking about infrastructure observability, which is true and which is very important actually, because if we are running a half infrastructure, your resilience is better, your reliability is better, and your customers are happy. And usually when you are talking about infrastructure observability, we are talking about monitoring Kubernetes systems. For example, if your system is scaling or not, if you have new pods, or for example, if you're running a Kafka broker, you may pay attention on disk size, disk throughput, and many other things, okay? Which is important, as I said. But when you're talking about observability, we need to talk about also application observability, okay? Which is a little bit more complex because most of the things on the infrastructure side is made, we have metrics, we have logs by default, because logs is the most common observability data type. But when you're talking about application observability, it's a little bit more complex because some systems is not prepared yet to export all the things that we need, okay? Because sometimes we need technical metrics or technical information like logs, traces, and metrics, but from the application perspective. You want to know what is the P99 of latency for a specific application. You may want to know how many messages this specific application is producing for your message broker. If you're using Kafka, RabbitMQ, anyone, is the same concept more or less. Okay. And on the application side, you may also understand. You may want to understand also some business metrics. So, as given the e-commerce example that I gave you in the beginning, you may want to know how many orders your customers is doing by second, by minute. What is the click path on your system? How users navigate on your platform? And collecting all those information, you can start thinking about like, places in your system that you want to add a lot of focus to improve resilience, to improve performance, to reduce error rates, and so on and so forth. Okay, but collecting all those information sometimes is not easier, especially if this is not built in your framework that you are using. And it leads us to a work that most of the engineers don't like to do, even less the product manager, which is instrumenting code to get in the required information. Okay. So if the idea of this talk is to show some strategies to let engineers putting their focus on the things that really matters for them, like delivering features, measure user experience, getting business information, let's avoid engineers spending time adding telemetry to collecting technical things like HTTP requests, Kafka throughput, DB the latency, and so on and so forth. Okay, so this is what we're going to show you today, how we can collecting standard metrics without requiring engineering efforts. And this is useful to make some standard pros across your company and ensure that doesn't matter the language, the language that you are writing your system, you are collecting the same kind of information using the same structure. Okay. Okay, cool, folks. And we are talking about instrumenting code. And instrumenting code to collect as much as we can. So as an engineer, you want to know every single information from your system because everything is kind of valuable, but do this kind of job can quickly become overwhelming for you and for your team because you need to use engineering time to add metrics that might be provided by platform. If you're having a platform team, for example, a DevOps team that can do all the automations and the strategies that we're going to see today on your company, and may give you such information. And you can use your engineering time to do instrumentation to collect things that really matters for your system and for your product engineering and so on. And for example, we have a meme here, and of course this is just a joke, but a funny one, because when you're talking to product engineers that we need to instrument our code, we need to spending engineering time instrumenting codes instead of delivering features, it automatically get a low priority. Okay, and as I said, this is just a joke, folks, because of course we are talking about two different professionals looking for two different perspectives for the same problem okay. And when you are talking about when you are an engineer, you're trying to push as much as you can the better system to production. You want to build the more scalable, the more performant system. When you're a product engineer, you want to push to production the better product you can with the better features, the best user experience, and so on and so forth. So this is a trade-off. We need to talk to each other. And of course, if your platform team is providing you some basic information on the platform side, you just need to instrument your system, your code for the information that really matters for your product, for your team, and you can use the information to improve your product, and your product engineer can use the same information because it's a tech and business information, okay, and observability information. So let's move forward and let's see what are the strategies that we're gonna see today. Those are three. Okay, cool, folks. So those are the strategies to not overload your engineer team: the proxy strategy, the opentelemetry strategy, and the ebpf strategy. I have a blog post for every one of those strategies on my Medium account. You can check this information there as well, and feel free to reach me out and provide any feedback that you may want. And people, the idea of this strategy is to design and give you to your engineering team a solid foundation of observability without having any code change. And what I mean by this is simple. You as an engineer, when you want to deploy a service on your company infrastructure, you don't want to change your code to start collecting common metrics such as HTTP requests, gRPC streams, Kafka consumers, and Kafka producers. You don't want to instrument your code to collecting latency metrics. You don't want to instrument your code to start collecting basic tracing information, and so on, okay? Because you want to leverage your platform. You want to consume observability as a service, okay? I like to say that because we are offering many services as a service, like CI as a service, Kubernetes as a service, deployment as a service, but you also want to have observability as a service. You want to deploy your system without any code change, and you want to start collecting telemetry data, okay? In the end, the idea of this talk is to provide some useful insights that you may use in separate each one or combine those strategies together to get the information that you may want, okay? After I show you the live demo of each strategy, we are gonna see table of comparison, so we can compare each strategy, the benefits, the pros and cons of each one. And this may help you understand when you choose one and when you choose another one, and so on. Okay, so folks, I hope you enjoy. Like, this is gonna be very fun right now because it's live demo. You're gonna see things in action. You're gonna see open source solutions, and yeah, let's move forward and see the proxy strategy in action. Okay, cool, folks. So let's go for the first strategy, the proxy strategy. We are going to leverage existing piece of infrastructure that you probably already have on your company, which is your web proxies, okay? If you're running HTTP applications, you probably have something like Nginx or HA proxies, which are very common solutions when we need this kind of strategy, but this is not coupled for any technology, okay? I'm gonna use Nginx as an example just because I'm familiar with Nginx, but you can do the same with HAProx or any other web server that you know better, okay? And the concept is the same. So as we can see on this slide, we have a diagram showing the flow. So we have an ingress proxy. The ingress proxy is responsible to handle the HTTP request that's coming from outside your platform to inside your platform, and then it's redirecting to the proper service, so service A or service B. And on the left side of the diagram, we have the three telemetry backends, okay? We have Prometheus for metrics, Jaeger for traces, and open source for logs. And those backends are going to store the telemetry data produced by the ingress proxy, okay? This is a very simple one. And the idea of this strategy is if you are using web applications, and this strategy is very web specific, okay? You can ensure that you're gonna produce standard telemetry data like traces, metrics, and logs, and independent of the technology that you are using to build your service. So let's imagine that the service CA is using Java, and the service CB is using Golang. You can ensure that the telemetry data that we are collecting is using the same standard and doesn't care about the technology that the service is using. Okay, so let's move to the VS Code and see the very simple strategy we have. So quick spoiler, first thing that you see here is a makefile. I'm just using this to abstract a few commands and type a little bit less. But on the app folder, we have a very simple Golang application where we are mimicking a checkout, an e-commerce checkout process. So when user is doing a checkout, the checkout service is going to call the payment service to do the user payment. Okay, very simple. And here you can see a few lines of Go code, not important for us. And then we have a Docker file, simple as well, none especially. And then we have the Docker Compose, where we have a few containers running here, and I'm gonna tell you about it a little bit. So we have two proxy containers. The first one is the ingress proxy, the ones that I told you. It's handling the requests coming from outside your platform. And then we have the egress container, which is acting as a ambassador container. So which is handling the request that's going out from one service to another service. Okay, and having those containers, those two proxies, we can collecting and connect points between service A and service B with distributed traces. Okay, it's very similar what we have when we are using service mesh in Kubernetes. Okay, we have like containers handling in front of every application to do this magic. Cool. Besides that, we have checkout and the payment service, and then we have the exporter for both ingress for both proxies, for the ingress and the egress. I'm using Prometheus exporter, which is collecting, it's creating metrics using the Nginx HTTP logs, which are very useful, and we already have a lot of information there. So we are getting the logs and creating metrics from the existing logs to understanding latency, requests, heights, and so on and so forth. And then we have Prometheus and also Jaeger. Okay. So before we move to the next step, folks, let me come back to the for the proxy configuration, and I would like to highlight that we are using a very specific image for this container, which is the Nginx Open Tracing. And this Docker image already have all the required modules to starting spans when a request is received, and then export the spans and the traces to the tracing backend, in our case Jaeger. Okay, so an important thing here is I know that we already have OpenTelemetry version that was released very in this week. I didn't update this demo yet, but if you are starting doing this strategy right now, I really recommend you using the OpenTelemetry version and not the Open Tracing. Okay, cool. So for the ingress configuration, we have something very simple. Okay, for the proxy configuration, it's like a forward proxy. We are just getting the request and forward this to the service, and we are just leveraging the proxy to collecting the telemetry data without needing to change anything on the code. As we saw, the Go application is very simple, and we don't have any instrumentation to collecting HTTP metrics. Okay, cool. So we already know the basics. We already know all the things, and then we can just start generating a few load on those servers and see the things happening. So I will open the terminal. Let's get the make file just to understand what's happening behind the scenes. And the first thing that I'm gonna do is run make setup. Make setup is going to start all the containers using Docker Compose up. And also I have all the containers up and running. As we can see here, all those logs are here. We can go to the web browser. Let me switch to the web browser. And, actually, let me just fix. Foda-se, mano, não acredito. And now, on the web browser, we can access localhost 9090, which is Prometheus web interface, and we can see the Prometheus targets here, the two Nginx products, the ingress and the egress, and the Prometheus itself, okay? So back into the VS Code, let me see which is the port that Jaeger is running, because I don't know by heart, and it's 6686. And then we are going to move back to the browser, and we are going to access localhost and then the Jaeger port. So we don't have anything here, okay? The only service we have is Jaeger itself, because Jaeger is collecting its owner traces. And now we have all those things running as expected. We can start producing a few loads to this infrastructure. So let's go back to VS Code. And then we are going to open a new terminal and using the make command we have here, which is make test. What make test is doing is just creating a few load on the checkout service using Vegeta. Vegeta is a very simple load and test in CLI. I think this is just amazing for this kind of purpose, okay? And I'm gonna run a load test against the checkout API during 6 seconds, okay? So let's go. And it's making a lot of HTTP requests. So if we can go to the logs, we may see a few logs happening here. And I think we may already have a few data available. So let's go back to browser. And then in the browser, the first thing that we're gonna see are the metrics that we're collecting. So we have a few metrics named Nginx. Let me refresh because the metrics might not be available. Yeah, we already have it. And then we have the Nginx HTTP request count total. So we have few things here. Okay, we can see all those things. And then if we run an expression like HTTP request and sum these by, I don't know, service, URI, and status code, we can see all those things, okay? And then we can see this increasing over time, which is very cool. And since we are doing linear requests, we are not gonna see this going up and down, but here we can already know the information that we need, okay? We can measure the amount of HTTP requests for a given service, and that's cool, that's pretty cool. And using that information, we can see the amount of HTTP requests. We can use these to building SLOs, for example, like error rates. We can use that information to measure HTTP responses, because we should have probably, I'm not finding right now, but we should have a few metrics about latency, but we may know which is the, for example, the response size for each request, okay, which is also very useful information. And using the Nginx exporter, you can build any metric you want using the Nginx logs, okay, so you can get in the logs and you can build all the required metrics that you may need. Those are just a few examples. And as I said, those are standard metrics. It doesn't matter which technology you are using behind the scenes. The next telemetry data that we can see are the distributed tracings, okay? And then we can see that we have two services here. The first one is the checkout, and if we find traces from checkout services, we can see that the checkout go to payments and so on. So we have two hopes for every service. This is Nginx internal, okay, and we can see in that way we can look for system architecture, and we can see, for example, the service is not zooming again. Let me see if it's better on the service. Yeah, we can see the checkouts. It's using the payments API, and if you have many services, you'll be able to see this diagram architecture, okay, which is nice because if you are using a microservice solution where you have many microservices talking to each other, it's very hard to know only by knowledge that what are the service communication flow, okay. One thing that's very important, those distributed information are useful, but it doesn't give much detail about the service internally. So you cannot identify performance issues inside your service using that information, okay? This is useful to understand the network hopes on your platform, but not useful to identify internal problems, okay? But giving that information, giving that telemetry data, your team can start looking and see, okay, we are talking to this service and this service, and then they can see, okay, on this payment flow, I want to improve the details, and then the team can go and add telemetry for the flow and the path they really want to know, okay, and they can reduce the amount of work they need to do. Cool. So this is the proxy strategy, folks. This is very simple. As I said, the idea is not like any rocket science. It's just using a piece of infrastructure service that you already have on your company and start collecting a few telemetry data, okay? So before we finish, just talking about the logs. Logs are available on your host. So for example, you can see all the logs produced here, okay? We are producing a lot because we are generating a bunch of requests. We don't have any errors in that case, but we could mimic some errors, for example. And also we have this. Those access logs, you can use some log shipper like opentelemetry or FluentBit to collecting those logs and ship to open source solution. And my advice is, since most of the information you have on the logs are now available on metrics like status code, path, you can just choose to drop some of those logs, especially the 200 stats codes, okay? This is just an advice that might save you some money in terms of storage and also networking. So this is the first strategy. We are going to move to the next one now, which is the opentelemetry strategy. So let's go. Okay, cool, folks. This is the second strategy, the opentelemetry strategy, and in my opinion, this is the coolest one because this is using the opentelemetry, which is an amazing project maintained by amazing people, offering a lot of integration, and wow, this is very interesting, okay? And this strategy, folks, also aims to rely on an infrastructure piece that you will deploy on your company, and it will start collecting metrics and traces out of the box for you. Okay, so the OpenTelemetry project, it's a huge project composed by many different parts, such as the OpenTelemetry specification, the OpenTelemetry collector, and also the OpenTelemetry ebpf, auto instrumentation, operator, and so on and so forth. We are going to using today the OpenTelemetry open instrumentation and the OpenTelemetry collector to auto-generating and collecting the traces and generating the metrics. Okay, so looking for the diagram, we have an hotel agent, OpenTelemetry agent, running your host and receiving the tracings that will be produced by your applications. The OpenTelemetry agent is going to process the traces and creating metrics, and then expose metrics and traces to the backend, for metrics to Prometheus and traces to Jaeger. Okay, it's like kind of language agnostic, so it doesn't matter which language you're using, if you're using Python, if you're using Java, and so on and so forth. Okay, so let's move to the VS Code. On VS Code, we have almost the same thing. Before I show you the solution, I'm just gonna run make setup to ensure I have everything running, and I will start producing a few loads on the services. It's using the same Vegeta command that I show you on the previous demo. So we will like looking for the configs we have here. So first I have the app folder. On the app folder, we have a very simple Python application mimicking the same behavior, checkouts and payments doing the same flow. Okay, and folks, as you can see here, we don't have any OpenTelemetry or Prometheus or Jaeger code. Okay, we are not creating traces, we are not creating metrics. This is a plain and standard Flask Python server. Okay, this is just to bear in mind. All the things that you're gonna see, it's auto-generated. So looking to the Docker file, this is where the magic starts to happen, because we have to install a few Python packages on the host, which is as a dependency, like the OpenTelemetry distro, the exporter of the OpenTelemetry format, and also we need to run a few bootstrap commands to configure everything that we need on the host. And then we have the OpenTelemetry instrument surrounding the Python command. Okay, it's like running the OpenTelemetry instrument, and this is starting a process of Python. Okay, when we are doing these, folks, and this is where the magic starts to happening, because the auto instrumentation project of OpenTelemetry is doing the same thing that the vendor agent is doing. It's changing your code in Python casing during runtime to adding telemetry code. So the OpenTelemetry auto instrumentation is changing the Python code to initialize tracing context and ensure that we are propagating the tracing headers when we are doing HTTP requests, when you're producing a Kafka message, reading the trace context when we are receiving a request or consuming a Kafka message. And those are just examples. This is doing a lot of things behind the scenes. Okay. Cool. The traces are being produced by this application will be sent by the OpenTelemetry collector. Okay. Before I show you the OpenTelemetry collector configuration to you, let me show you the containers we have running inside the Docker Compose. We have Prometheus, and then we have Jaeger, and then we have the OpenTelemetry, and then we have the services containers where we have the checkout API and also the payments. As you can see, I have for both containers a few environment variables defined. We have the OpenTelemetry traces exporter, which is going to be the OTLP, what is the format that I'm gonna export traces, which is the service name, in this case is checkout, and what is the OpenTelemetry collector endpoint where this application should push traces, which is hotel, and on the port 4317. Okay, hotel is the container running the OpenTelemetry collector. Good, pretty simple. Moving to the OpenTelemetry collector, we have the OpenTelemetry collector. And the OpenTelemetry collector is a piece of software responsible to receive telemetry data, process the telemetry data, and then export the telemetry data. This is literally a software pipeline, okay? So you can receive, process, and export. And we can see we have a pipeline section on the OpenTelemetry collector config, and we have two pipelines running here. The first one is the receiver, which is the OTLP. So the application is producing the traces for this receiver, and then we have a batch processing. We are just batching the spans and exporting those spans in batch to the backend, which is export another OTLP, and then the OTLP it's sending to the Jaeger endpoint. And on the exporters, we are also sending to something named span matrix. And which is what is span matrix? Span matrix is a connector, and connector is a part of OpenTelemetry collector that acts as a receiver and also the exporter. So it's like literally a connector. It can receive and export on the same time. Okay, so for every span we are exporting, we are sending to the span matrix. The span matrix is receiving the spans, processing those spans is basically creating metrics from the spans, and later we are using another pipeline named matrix span matrix, and we are getting data from the span matrix since we can receive and export data, and then we are getting from matrix from span matrix, and we are exporting to Prometheus remote write, which is remote writing to our Prometheus server. Okay, this is basically that, folks, and the part of code is responsible to creating metrics from traces is the span matrix connector. Okay, so the OpenTelemetry auto instrumentation on the Docker image is changing the Python code to initialize the tracing context and ensure that we are propagating headers and reading headers, and the collector is receiving, processing, and export to the matrix. Okay. Just one note, the way that I did on the Docker is the simplest way that you can do to have auto instrumentation running. Okay, there is another approach. If you are running Kubernetes, you can use an OpenTelemetry operator, and you can inject sidecars on your pods based on your technology. So if you're using Java, you just need to annotate your pods with Java annotation, OpenTelemetry Java annotation, and OpenTelemetry collector is going to do all the magic to you, the OpenTelemetry operator. Okay, but I'm not show you this today because it's a little bit more complex. So we already have this running for a while. Let me see, probably for a few time from now. Let me just ensure one thing. I guess I forgot to run make test. Yeah, but let's running and let's switch to browser. Now we have we are on the browser. We can go first on the Jaeger view, and we can see the traces from the services we have, checkout and payments. If we look to one tracing in specific, we can see that we have three spans. We have the first span, which is the checkout. So when the checkout service receives the request, and then we have a checkout action get, where the checkout service is doing an HTTP request to the payment service, and then we have the payment service receiving the request. Since the payment service is doing nothing, we don't have any kind of continuation span here. But if we're consuming a Kafka message or another thing, we're gonna see this span as well. Okay, we can look to those spans and see that we have a few useful information like user agent. In this case, Vegeta is written in Go, so the user agent is Go client. We have which is the host port, the pure IP, the opentelemetry library name. We also have a few process tags such as the SDK version. It's also showing it's an auto version, auto instrumentation version. Okay, and the same is true for payment service. The difference here is the user agent is Python because checkout service is a Python server and not a Golang. Okay, cool. As we can see on the OpenTelemetry strategy, we have more details about the service internals. The thing that we didn't have on the proxy strategy, because we are collecting on the proxy strategy, we are collecting telemetry data from the layer above. Okay. Well, we also have the system architecture, as we can see here, very useful as on the other demo. But since we are using OpenTelemetry in this spans metrics and we are creating metrics from traces, we can leverage another Jaeger feature, which is the monitor feature. We can just see an APM view, like by service and operation under this service. We can see the request rate, the P99 latency, we can see the action, and we can also see the impact of this action on the services. So this is related. So what is if this action is most used or less used? Okay, this is very nice and very useful for quick and troubleshoot. If you want to see this on your Jaeger page, Jaeger is reading data from Prometheus to build this screen, which is kind of nice. Okay, so moving to Prometheus, and if we go to Prometheus on the 99th port, we have two metrics here. The first one is the calls, which is basically a rate of actions. Okay, in this case, since we are using an HTTP request, this is a rate of HTTP request, and then we can run a rate sum 5 minutes by HTTP method, status code, and then service name, and we can see this going up. Okay, let me just reduce this a bit, and well, this is it. So if we are doing Kafka producers, we're gonna see the same thing. Kafka consumer, the same thing. Okay, under the calls. So it's important to understand this kind of operation. We can also, of course, have in the span name, for example, to help you understanding what is the action is being executed on this part of code, but it's basically that. Okay. Another useful metric we have is the bucket duration bucket, where we can measure P99, P95, as we saw on the Jaeger screen. So let's do sum by Ali and service name, and we're gonna use a histogram quantile P99 for this, and we can see like last 5 minutes the P99 for the checkout service is around 8 milliseconds, and for the payment service is around 1 millisecond and a half. Okay, well, those are very useful metrics. Again, we are doing all those things without any code change. We are just deploying an agent on the host or changing the Docker image. So this is very simple to be executed by someone from your platform team. And which is nice, we are ensured that those metrics are being produced using our open standard, which is the OpenTelemetry specification. Most of the vendors are supporting OpenTelemetry. data. Open source solutions are supporting opentelemetry data as well. And if you are using a vendor which is not supporting opentelemetry format, I do recommend you move away from this vendor because it's not good for you. Keep using proprietary telemetry data, okay? And which is nice as well because it doesn't matter which technology you are using to build your service. If you're using Python, if you're using Golang, if you're using Java, all those metrics will have the same standard, the same labels, and so on. So this is very useful, especially if you want to build dynamic dashboards, dynamic SLOs, and so on. Okay, folks. So I hope you enjoy this demo. For me, this is one of the coolest one. And then we are now switching to the 31, to the ebpf strategy. Alright, folks, so this is the 30 observability strategy to not overload your engineering teams. And this strategy is like very interesting because it's using ebpf. So ebpf is an emerging technology, especially on the cloud native space. You may see a lot of products using ebpf for observability, security, networking, and so on. So ebpf, for those that don't know what this means, it stands for Extended Barclay Packet Filter. BPF, it's very common on the Linux kernel, and ebpf, it's like BPF with some tuning of extra features and really cool extra features actually. Okay, and the idea of ebpf is extending your Linux kernel to trace, monitor, and analyze like system performances and behavior. So you can collecting things that's happening on the kernel level and provide insights and provide those informations to the user space, okay? And ebpf is not such a new technology, but you can see a few products leveraging ebpf. We start seeing a few more nowadays, but it's not highly adopted yet, okay? For many reasons, people is still not like it's discovering and so on, okay? So the idea of this demo, folks, is basically the same idea. It's like we are gonna having an agent that will be able to collecting all the signals that we need, like the metrics, trace, logs, from the application level, okay, not only from the infrastructure, but as we did for the for the other demos, we're gonna use the same concept of collecting application level observability, okay. Well, so let's move to the VS Code, and this demo is gonna be a little bit different because I'm really focusing on Kubernetes strategies right now, okay, because I'm gonna be using a solution which is Kubernetes based, but we already have many other options to the ones that not using Kubernetes, okay. So what we have here, it's like pretty simple. We have a cluster, and then we're gonna start in a Minikube cluster, and then we're gonna install on the cluster Cilium. What is Cilium? Cilium is a networking interface for Kubernetes, okay? So we have many like Falcon, we have like some cloud specific CNIs, cloud container network interface like AWS, CNI, and Cilium is another CNI, okay? And Cilium is fully built on top of ebpf, and it's using ebpf for networking, for loading balance, and many other things, and now also using ebpf to provide observability inside your cluster. So using Cilium and its ebpf agent, we can collect metrics like TCP, HTTP, networking metrics, and so on, and we can also understanding what is the networking flow inside our cluster, okay. Very similar with the information we have on the Jaeger diagram architecture, but this is not, it's built in not using traces, it's built in using network flows, okay? But the concept is the same, it's just another sign or another kind of information that we can use to get the same site, okay? So I have all the commands that I need to install Cilium, to install the monitoring stack on the Kubernetes cluster, and another things like we are leveraging some applications from StalWars to start collecting traffic from there, okay? I will not cover each command as I didn't on the previous one, but you are free to check this out later. All the source code will be available on the GitHub, and you have access for that, okay, folks? So meanwhile, let's start creating make setup as we did for the other ones. We are going to start in a Kubernetes cluster, and then we will starting installing all the things that we need, like Cilium, Grafana, Prometheus, and so on, okay? So as soon as it's finished, we will be back here. Okay, cool. Now we already have all the components running on the cluster. So if we run kubectl get pods -a to get pods from all namespaces, we're gonna see all the pods that we need to have on our clusters. Like we have the Cilium operator, which is the operator that's going to ensure that we have each agent has Cilium agent running there, that the Cilium is running health, it's collecting all the metrics and so on and so forth. So we have few Kubernetes pods like core DNS, etcd, it's pretty straightforward, those one. We have Rubble, Relay, and UI, okay? And I have other Kubernetes pods as well. So the thing here, it's like Cilium by default is it's not providing any kind of observability, okay? The Cilium project, it's working in a very specific way, which is Kubernetes CNI, networking, and like loading balancing, ensure that when you create a new pod, the pod's getting IP, the node's getting IP. It's like doing the communication with your cloud providers to getting IPs from your network and so on. But the Cilium project has another sub-project named Hubble. So Hubble is a observability solution, if I can say that is connecting to, it's leveraging Cilium to getting network flows from your pod communications and then extracting metrics and providing network visibility from your cluster and the applications that you are running. Okay, so this is what is Cilium and this is what Hubble, and we are gonna see this right now. For this, we need to have port forward few components on our machine. Okay, let me show you the pods again and explain another thing. So we have each agent with a Cilium agent, each Kubernetes nodes with a Cilium agent running there, watching every network communication inside those nodes, okay? And then Rubble, it's getting the network flows and building all the observability that we need, creating metrics and so on. And we have a few other things here, which is like we have a Grafana, and then we have also Prometheus because we need store the time series that Rubble is creating. And we have Death Star and also a TIE Fighter, X-Wing, to provide some loads inside the cluster, and then we can mimic like services communicating to each other. Okay, so the TIE Fighter and the X-Wing is like doing some HTTP requests to Death Star, and we're gonna see this in action like right now. Cool, so let's port forward a few components, like make port forward and then relay, because we are running all those things from our machine, and then this is like Cilium requirement because because Cilium UI needs to talk to Cilium Relay to getting the information that we need. So now I'm gonna run get port make port forward UI. Okay, meanwhile, we can switch to browser. And then on the browser, let me switch to browser as well. We can localhost is 2000, I guess. It's 12,000. Okay. This is the Rubble homepage. Okay, so you can see all the namespace we have inside the cluster, and then we can start. If we click on the namespace, we can see all the applications is running inside this namespace and the traffic flowing inside each application. Let me show you another one, like Kube Systems, the same idea. We have a Rubble UI and a Rubble Relay running there. What else? On Cilium monitoring, we have Grafana. Let me see if it's low. No flows found for now, but because we don't have any trafficking happening inside this namespace, but we can back to default, and then we can see that X-Wing and TIE Fighter is talking to Death Star. Okay, and we can see all the network, all the action happening right now, like the post for the V1 requested landing. Okay, and we can see like forward, and if we click on those things, let me see, maybe down below, if we click here, okay, I just missed this, we can see few details, like when this communication is happening. We see if it's a traffic direction, if it's ingress or egress. What else? We know what is the source pod. So if you have many pods, you can see from where this network action is coming from. And you have a few labels. We have the IP, we have the destination pods, we have destination labels, like a lot of useful information. Okay, and then we can run a few filters here, like we can filter by name. Let me see, label Kubernetes. I'm not seeing this, but maybe clicking here, namespace default. It's already, you see, label equals namespace equals default. This is how we are filtering. And this is the same thing. If we click here on the the source pod, we can see a few labels from the pod, from the destination, same thing. Okay, and that's basically that from Cilium. Okay, we can know a few network informations, but not very special. But this is more like a UI view, because from that application you cannot create any alerts, you cannot create any dashboard. Okay, this is more information regarding Cilium and Rubble than like a properly observability solution. Okay, but how look we are, because Cilium and Rubble export all those informations. Especially the metrics is being created to a time series database such as Prometheus. And then we can move back to VS Code. Okay, so let's go back to VS Code, and then let's create a new tab here, and let's port forward Grafana. Now we have Grafana running. Let's go back to the browser and open localhost 3000. And we have a few dashboards on Grafana. The first dashboard is like about Cilium operator. Okay, this is not what we really need. It's more related to Cilium operator healthiness. What else? We have Cilium metrics, which is useful as well, but not what we need. Okay, we may see like how much the BPF memory is being used, if we have any ebpf errors or not, system calls, maps, and so on. But this is not what we want, right? Let's see again what else we have. We have two another dashboards which are more related to Rubble and the metrics. Rubble is exporting based on the network flows. So we have Hubble dashboard by itself. We may see the amount of flows. And the flows, folks, we are talking about here, it's all those things is happening on this tab down below, okay, where I'm hovering the mouse. So each communication between a source and a destination is considered a flow. So we may see the amount of flows we have, we may see the type of flows we have, like it's trace, or if it's a L7 network flow. So in this case, we have a few L7 flows because we are doing HTTP requests, okay? And so on. So we may see if we are losing any packet, and that's it from this dashboard, which is nice because we start already seeing a few HTTP metrics that are being created on top of the network flow Cilium is collecting, DNSs and so on. But what is nice here, it's also the Hubble L7 HTTP metrics by workload, where we can see what is the source workload, for example, X-Wing or TIE Fighter, and then we can see the destination. In this case is only Death Star. We don't have any other destination, but we can build, we can see metrics like by status code, by source and destination, and so on. So let's explore. We may see also latency, as we can see here, like the P99 and the P95. We can build in like SLOs on using these metrics. We can build in alerts for error rate, latency, and so on. So just to show you, we can see a few metrics to explore labels. Let me see, 5 minutes, and we can see a few labels here. Like we have the destination, the namespace, and the workload, the destination IP as well. We have which protocol we are using, because we may use like Kafka protocol, we may use HTTP or any other kind of things, okay? We may use HTTP2 and so on. We have the source workloads and the source namespace, which is the method, and I guess we also have the status code in some place here. I'm not 100% sure. Yeah, we have the status, and also we have the method. So we may create inquiries like, okay, on the last 5 minutes, I want like by destination source workload, code, and method, and we can see something like that. Okay, I guess it's status. Maybe it's not. Yeah, it's status. So we may build some SLOs, like all the requests by the bad requests, and then we can status something like that. Okay, I just have a typo here. Oh, it's the opposite. Yeah, and then we may have something like that. Yeah, I'm broken the query, but I don't know why. Yeah, because it's 0. Yeah, this is the reason, because we don't have enough requests with the errors. But yeah, you got the idea, okay? So you can use all those metrics on the same standard that we have on the other. Doesn't matter which technology you're using, if it's Java, if it's Golang, if it's Ruby, we don't care. The metrics we are collecting are the same. The network flow we are collecting are the same. We don't need to instrument our codes to get all those metrics, and which is nice. Again, this is on the application level. It's not on the load balancer level. Okay, it's pretty close to your service. And then this is the idea of Cilium, ebpf, and so on. Okay, so back into the slides. I would like to add a few things here. Is like I've been using Cilium as the solution for this demo, but the truth is When I was building this demo, Cilium was the most mature technology for observability using ebpf. But nowadays we already have a few more technology that I didn't test it yet. Like we have opentelemetry ebpf agent, which is providing a few metrics, not very detailed as Cilium is doing, but I do believe this is a project that's going to be very mature in a few weeks and a few months maybe. We are still working to have Helm charts to make this agent installation easily, and the OpenTelemetry team is working to improve this. I know that community is building a few other services using ebpf, but I didn't test yet. Okay, so for sure Cilium is not providing all the signals we need. Okay, we are talking about a more related to maybe we are not including traces and logs. Okay, we are only talking about metrics, but this is a starting. ebpf, as I said, is it's continuously growing technology. So day after day we see the community involving the observability and security solutions using ebpf. So I do believe this is a technology that you must watch for your observability systems, not only for metrics and traces, but also for profiling. We see many profiling solutions like Parka doing CPU and memory profiling using ebpf. Okay, folks. So this is the third strategy, the ebpf strategy. Again, the idea is to not change any line of code, to include instrumentation, and we collecting as much as we can using platform. Okay, so this was the last one. Let's now looking for a table comparing both of them. Okay, now you might be asking, what is the best solution? What is the best strategy to not overload my team? And this is the answer that engineers usually to hate, but it depends. Of course, it depends of your infrastructure. It depends your team knowledge. It depends how many people you have working on platform, abstracting features, provide things as service inside your company. So of course, it depends always, but we have I list a few things that I think that might be important, like technology agnostic, context propagation, environment agnostic, and also multi-telemetry data. So from the tech agnostic, what I mean by this, if I have different implementations based on the technology I've been using. Okay. And for proxy and ebpf solutions, this is completely agnostic. Okay, it doesn't matter the technology you are using, the implementation will be the same. Like on the proxy, we are collecting on the proxy level. ebpf is doing all the magic on the kernel level for you. Okay, the OpenTelemetry instrumentation, it depends on the technology you are using. Okay, the example that I show you, it's Python. It's a Python solution. If you are using, I don't know, C#, this is another way to implement, like the same concept, but in another way. If you're using Rust, another way. If you're using Node, so and as well. So OpenTelemetry instrumentation depends on your technology. So you might have different implementation based on the solution you have. But in the end, like it worth. You saw the power of OpenTelemetry instrumentation and the things we can do with OpenTelemetry collector. I do believe that you should give a try for that. Okay, so the things that ensures context propagation, like the proxy, it kind of ensures. Okay, it only ensures proxy context propagation on our demo because we have an ingress proxy and an egress proxy. So I'm listening to all the traffic that's incoming from my platform and all the traffic that's going out from my services. So, and the other things is we only see context between proxies. We don't see things happening inside the application. Okay, so we cannot using this information to troubleshooting the problems inside the application. This is what I mean regarding traces. Okay, regarding the metrics, well, we have the highest level possible. and as much closer from your customers your proxy is, more realistic will be the latency and the error rates that you're gonna collecting from your system. Okay, the opentelemetry and the ebpf, yeah, it ensures context propagation. Okay, the opentelemetry, we saw the things as well going through one service and another, and details inside the service. The ebpf as well, it depends of course the solution you're using. Cilium is not talking about trace, but if you're trying another solutions that is ebpf trace based solution, it's gonna work. All the three options are environment agnostic, so it doesn't matter if you're running Kubernetes, if you're running virtual machines, if you're running bare metal, so it's gonna work. Okay, the Cilium is only working for Kubernetes because it's a Kubernetes CNI, but the ebpf solution is not Kubernetes based technology, so you can use opentelemetry ebpf collector on your Linux machines. Okay. All those are providing different kind of telemetry data. We have logs from there, we have traces, and also we also have metrics for sure for all those three options. Okay, folks. And as I said, it depends. You need to understand your use case, you need to understand your requirements and your capabilities to choose the best fit for you. One of them is gonna provide for you what we need and the metrics and the telemetry data that you are looking for. Okay, cool. But there is another option, and if I'm able to implement every solution, why not do this and collecting metrics in different levels? Okay, like using the proxy strategy to collecting metrics on the proxy level. Okay, the proxies that are closer to my customers, and then I can measure pretty close customers' latency. Okay, why not using auto instrumentation to start collecting traces from my applications without any code change and providing all the information that I need, and then I can use an opentelemetry collector to process and enrich this telemetry data. And why not using ebpf as well? So then I can collecting network information and also application metrics from the kernel level, because the kernel is the best place ever that we can use to collecting observability and security data. Okay, and then you can have different point of views and you can decide which metric and which it's better for each level you are looking for. If you're looking for network levels, probably ebpf and the Cilium solution is going to be better for you. If you're only looking for application level metrics, the ebpf, the opentelemetry is going to be better, and so on and so forth. And then you can use all those strategies, provide as much insight as you can for your engineer teams. They can build in alerts, they can do whatever they want, or you using all those standard metrics, you can automatically providing them dashboards and now alerting out of the box. Okay, and this is the great thing from those strategies, to ensure that the teams are gonna getting default observability for their services without any code change. They can focus on deliver features and make the product owner happy, the customer happy as well, increase revenue. And then when they really need to adding effort about observability, they're gonna adding observability for their context, for their specific use case. Cool. So folks, that's it. We can also try to join all those three strategies. So that's it from my side. I really hope you enjoy it. If you have any questions, feel free to ping me out. It will be my pleasure to talk to you and have a nice conversation about cloud native, about observability, and many other subjects. And thank you for being here, and thank you for listening. So see you folks. Bye bye.